So, good afternoon, guys. I welcome you to NEET World. So, this is day 11 of EAPCET 2026 Physics series. So, we have successfully completed 10 days, right? And we have completed our topics like units and dimensions, measurements and errors, kinematic parts, that is motion in a straight line and motion in a plane. And we have seen the equations also, right? And we are going with the next topic, that is laws of motion, that is Newton's laws of motion. So before starting, no, like let me wait for 1 or 2 minutes, like people are joining over here, right? I hope you are doing well, everything, right? And the people who are going to write the IPE exam, no, you need to prepare that also well, okay? No need to panic. We will do this also, okay? Like that IPE part also. Once December starts, no, like we'll start doing the IPE parts, okay? I guess we'll start the class now, okay? So, Newton's laws of motion. First, the topic which we are going to see is the force. So, what is mean by force? What is the thing we have learned about force in lower classes? So, force is nothing but like either I can push something or pull something. If I want something, no, like if I want to take the remote, I am pulling the remote from the some person, or if I want to open the door, what I can do, either I need to pull or push the door, right? So, force is nothing but either it's a push, wait a minute, either it's a push or a pull. So, it's a push or pull, okay? So, like day to day life, no, like we have come across the force. But what are the types of force? So there are different types of force. So one is electromagnetic force, next is gravitational force, contact force and nuclear force. Okay, so particularly in this lesson we will discuss about this contact forces, okay, which is normal reaction, tension and friction. So normal reaction means it's normal. The meaning of normal itself we can say it's a perpendicular, right? And tension, like when I'm using the rope or a string, like tug of war, people are playing, someone try to pull and the other person also try to pull, like the tension creates, na? Yes. And friction, obviously friction we know, whenever we walk also or whenever we drive a vehicle also, a friction will be there, like which means opposing force, right? Opposing force. So gravitational force, it's nothing but it's a weight, it's due to weight, we will say. Like when I talk about any objects in the earth, everything will be having a weight. Weight means nothing but mass into gravity, right? Mass and gravity. So when I talk about mass and when I talk about weight, both are different things, right? Mass is nothing but it's a scalar and weight is nothing but it's a vector, because mass only numbers will be there, like magnitude will be there, but weight it's towards down, right? No, direction also is there, so which means a vector quantity, right? Yeah, ask me what is the question, sir. I have a question. Okay, so electromagnetic force, gravitational force, contact force, nuclear force. Like a non-contact force, no, these are non-contact forces. Like contact forces are like normal, tension and friction, okay, and we'll see about that weight also, particularly the gravitational force, like gravity, due to gravity, no, so weight, right? So these are the things which we are going to deal in this particular lesson. Okay, and what about electromagnetic and nuclear? It's in 12th classes we will discuss. Okay, yes. So next one, yeah. So to move a football, no, like a football is there. To move a football at rest, I need to kick it, right? So some external agency is needed to provide force to move a body from rest. Obviously, if a body is there, I need to apply some force, right, to push the body, or if I need some body to pull towards me, or if I want to get towards me, I need to pull it, right? So consider a ball is rolling down an inclined plane, and to stop the motion, apply a force against the direction of its motion. Suppose if I keep a ball here, no, so it's an inclined or declined plane, whatever it is, okay. Now if I keep here, it is rolling towards down. So if I want to stop that, I need to apply some external force against the motion, right? Against the motion. So external agency is needed to retard or stop the motion. What is the meaning of retard? Like retard is nothing but it's opposing, like retard, like retardation, like deceleration, we'll say, no, like negative acceleration, right? Yes. So to throw a stone upward, I need to apply some force towards up, right now? Yes. So next one, a stone is released from a top, right? So this stone is coming towards earth's surface. This is my earth's surface, let me take, and this stone is came here. How it came? It is due to gravitational force, no? Stone accelerates due to gravitational pull of the earth, right? External agency can exert force on a body even from a distance. So the thing is, I can give a contact for the object to give a force on that, or else without contact also, if I leave an object, no, due to the external force, like that is gravitational force, the ball has been, or the stone has been pulled towards earth. So external agency can exert force on a body even from a distance. The external agency may or may not be in contact with the body. A bar magnet attracts iron nail from a distance. Obviously, no. Initially the nail was here. Right. Initially the nail was here. It has been attracted from a distance x or d. It has been attracted, no? Yes. So I can say that it can be physically, I can apply a force, or else from a distance also it can be applied, right? So these are the different kind of things which you need to know about before going into the lesson. Okay. Okay. So next one is law of inertia. Okay. So let me consider a body with velocity v. So we need an external force to stop or retard the vehicle, like friction, or I need to apply some brake, no? If friction is there, automatically the body will stop after certain distance. If I apply a brake, suddenly also it can stop, which means I am applying a force to stop that body, right? We need an external force to increase the speed also. If I need to increase the speed, I need to accelerate it, na? Yes, no external force, no change in velocity. So the thing is, if a body is going with some velocity, if there is no external force acting on a body, it will go with the same velocity. Or else, if a body is at rest, if no external force is acting on a body, the body remains at rest. You understood the point? When the body is going in a rest, I mean going in with velocity, no, if I apply some external force, then a body will accelerate or decelerate. That is okay, that one you can, depends upon the question. But when I am not giving any external force on the body, it will go with the same velocity, right? Yes. When a ball or a body is at rest, if I give any external force on the body, it will move until yes, if there is an external force only, or else it will be in rest, right? So this is the thing we can understand from the law of inertia. Okay. So inertia means resistant to change the body's velocity or body's motion. Okay. A body does not change its state of rest or uniform motion unless an external force compels it to change the states, right? So a body is accelerating and a body is retarding. Here a body is not retard, not accelerate. So here what happens? Some external force is acting, which means gravity. Yes, no. Here also some external force is acting, gravity also I can say, or friction also I can say, right? So it's accelerating. Again it is retardation, like deceleration has taken place. Here no, a body is going with the same velocity. Initially velocity was v, here also velocity was v. Here velocity was v1, here velocity was v2. Here v2 was there, again it has been changed to v3. Like it's changing, right? But here it has not been changed unless or until an external force is acting on the body, right? So no external force, no change in its velocity. Okay, this is the law of inertia definition. You can take a note of this. Done? Okay. So now here is the example. Okay. So here zero friction is there. Okay, zero friction. If I keep a ball over here, a ball will go until this height, again it will return back. So again it will oscillate like this, no, final height will be equals to initial height, and here no slope decreases, but the ball reaches the same height because there is no external forces acting over there. Here also slope is 0, so ball travels infinite distance until an external force is acting on the ball. So Galileo proved that on a frictionless horizontal plane, a body travels with uniform velocity. This is Galileo's experiment. Let's see here, a ball on a curved track, so zero friction is there. So when the ball rolls down one side and climbs up the other side, assuming there is no friction over there, so final height will be equal to initial height. The ball always try to reach the same height from which it started. So this demonstrates conservation of energy. Energy has been conserved, right? There is no loss of energy. When the second one, slope decreases there, no? So if the opposite slope is made less steep, like more gentle, means the ball still rises up to the same height though it travels a longer distance. Again, the final height is independent of the slope shape as long as friction is absent. If friction is there, obviously I can say that it won't reach the maximum height, right? If friction is not there, it will reach. If friction is there, it is not possible. So slope becomes 0, like slope becomes horizontal, right? So if the second slope is made flat, the ball can never climb up. It will go on to infinite distance. But since it has no slope to climb, the ball continues moving indefinitely with constant velocity, assuming there is no friction. So this is where Galileo concluded that on a frictionless horizontal plane, a body will continue to move with uniform velocity forever. Okay. Next one, type of inertia. Now we have talked about what is law of inertia, right? Next is type of inertia. Inertia at rest, first thing. Inertia at rest. So it is the inability of a body to change its state of rest by itself. To change its state of rest by itself. See here, passenger standing in a stationary bus experiences backward jerk. Why? Why he experiences a backward jerk? When the driver starts bus suddenly. Have you experienced ever when you are sitting in a bus, suppose driver stopped the bus suddenly, you are going front, yes, no? When driver starts bus suddenly, no, you are watching movie in mobile and the bus was at rest, suddenly driver start the bus, so you will go back like this, right, no? Or else you are going with some normal constant velocity or constant acceleration, okay, I mean constant velocity, right? So suddenly the bus has been stopped, suddenly it has been stopped, you will go front, right, no? Yes. So this happened because the feet of the passenger is in contact with the bus, come into motion, but the upper part of a body continues to be at rest. Only the feet of a body, right, no? Feet of a passenger passenger in contact with the bus comes into motion, but the upper part of a body continues to be rest, right? This is law of inertia at rest. Inertia at rest. So the next one is, here is another example. Suppose a coin is placed on a smooth piece of cardboard. Okay, have you ever tried this one, like when you are keeping a glass or any vessel and you are keeping a cardboard on the vessel. On that cardboard, some coin has been placed. You need to kick, like you want to kick out the cardboard somewhere, right? No, when you kick out, no, this coin will be placed down, but you need to apply some proper force on that card, otherwise the coin also will go down, right? Yes. So if the cardboard is stuck Suddenly the cardboard slips away, but the coin falls into the tumbler. This happens because of the inertia of the rest of the coin. Because I am applying a force on this card only, not on the, yes, I mean a force of the card, not on the coin, right? Now, if I kick out the coin, no, obviously the coin will go down. I mean card, no, the coin will go down. Okay. So next one, inertia of motion. So it is the inability of a body to change its state of uniform motion by itself. To change its state of uniform motion by itself. A body in uniform motion can neither be accelerate nor retard on its own. Right. Passenger sitting in a moving bus experiences a forward jerk when the driver stops the bus suddenly. Now only we have discussed, yes. This happens because the lower part of a passenger in contact with the bus comes to rest along with the bus, but upper part of a body continues its motion. Because everyone are like bus is going in a motion. The passenger also sitting in a bus. When I watch him, he is also in motion only. When I watch from outside, when I watch from inside, no. Like reference points are there, right? No. When he stops suddenly, the feet will be contact with the surface of the bus, which means the feet will be rest, but he continues to be in motion, right? He continues to be in motion. That's the thing, law of inertia of motion. So next one, yes, inertia of direction. So it is the inability of a body, to change its direction of its motion by itself. If a body is continuously moving with some direction, no, if I apply some external force, it can go in any direction, right? It can go in any direction, right? So a body continues to move along the same straight line unless compelled some external force to change it. Consider a small solid sphere connected with a string, which I am using in a circular motion, okay? Which I am using in a circular motion, right? Now string continuously apply force on the sphere towards the center. Right now, when I talk about this circular motion, a force will be there, centripetal force, it is towards center, right? This force helps to change the direction of the motion of the sphere to keep in circular motion, right? If the string snaps suddenly, the sphere moves tangential to the surface. If a body is rotating like this, if I leave a body in this point, it will go like this in the tangent. If a body is rotating like this, if I leave in this point, it will come like this. If a body is rotating in this direction, if I leave in this point, it will go in this direction. The tangential direction it will go. Right now, this is the thing, inertia of direction. Done. Okay. Next one is Newton's first law of motion. Okay. Every body continues to be in state of rest or uniform motion in a straight line unless and until an external force is acting on it or external agent is acting on it, right? So this sphere or a ball moves with a continuous uniform velocity or continuous uniform velocity. No, suppose a person is standing here, right, is kicking the ball, which means it changes its direction also, change its velocity also, right? So what Newton's first law says, every body continues to be in state of rest or uniform motion unless and until an external agent is acting on it, right? So this is Newton's first law. You can take a note of this. Done. Can we go for the next one? I hope it's clear. No? Okay. So Newton's first law of motion. Okay, here we'll see. Consider a book placed on a table. Okay. Weight is the force acting on a book due to gravity, and the normal force R is acting on a book by the table. See, no need to confuse about what is weight and what is normal force. Everything will come across, okay? As of now, we will discuss. Normal force is nothing but a perpendicular force. That's it. So normal force R is equal and opposite to the weight, which means R is equals to W. If I keep on a table, no, the book will be at rest because the weight of the book is acting towards down and some opposing force is acting towards up, which means equal and opposite forces are there. So object will be at rest, right? No. So the net external force is 0. The body is in state of rest, right? Okay. So we'll see next one. Next topic. Yes. Next topic is momentum. So momentum is nothing but it's a product of mass and velocity. Mass and velocity. So P is equals to mv. P is equals to m into v. So SI unit of this is, SI unit of mass is kg and velocity is meter per second. So kg meter per second is the SI unit of momentum, and momentum is a vector quantity. Momentum is a vector quantity. Suppose example is there, like 500 kg car is going with some velocity 50 meter per second. What is the momentum? 500 into 50, 25,000 kg meter per second. This is my momentum. Okay, you can take a note of this momentum formula. SI unit and momentum is a vector quantity. An example how to solve it. Done. Okay, can we go for the next one? See here, suppose so, yes, we have discussed about the thing, no? Momentum is directly proportional to the mass and momentum is directly proportional to the velocity, right? No, suppose so, let me consider two objects which is having the same mass 10 kg and other object which is having the same mass 10 kg, but first object is going with 10 meter per second, second object is going with 20 meter per second. Since masses are constant, velocity has been changed. What about the momentum? What about the momentum? So first one momentum is 100 kg meter per second. Second one momentum is 200 kg meter per second. Which one will have higher impact now? Which one will have high impact? Object with same mass, okay, but velocities are different, no? Velocities are different. So obviously the second one will have the high impact, right? No, if I take this one, this object, okay, if I throw with some u velocity, it will go and hit a person. But if I throw with some u plus v velocity, right, no, it will go and hit the person with high impact, right? Okay, and don't try that one, okay, don't hit the person, fine. Right, now we will go for that example. So mass of the scooter is 120 kg, but mass of a bus is 700 kg, right? Scooter and bus going with same velocity, 50 meter per second and 50 meter per second, right? So what will be the momentum? 50 into 120, I will get 600 kg meter per second. Here 700 into 50, 35,000 kg meter per second I will get. So which one will have high impact now? Obviously, like velocities are same for both of them. If this scooter is going hitting a person who is going silently in the road, and this bus is also going and hitting a person who is going silently in the road, but both are going with same velocity, but different masses will be there, no? Yes or no? Different masses will be there. So if a person got hit by the scooter, will get less injury, but if a person get hit by the bus, he will get big injury, right? No? Yes. So momentum depends upon both mass and velocity. Okay, if either mass increases also, momentum increases, or velocity increases also, momentum increases. Okay, if yes, so directly proportional to mass. If mass decreases, momentum also decreases. If mass increases, momentum also increases. Momentum is directly proportional to v. V increases, p also increases. V decreases, p also decreases. Okay. So the next one. The greater the change in momentum in a given time, the greater is the force that need to be applied. So there is a pistol, one with high speed, one with moderate speed. One with a high speed, no, will create a big damage over here, but one with a moderate speed, no, it will create a damage, but it will be less only. So will not cause much damage. Here much damage will be there. Why? It's because of the momentum. Because of the momentum. Right? No? Yes. Now, one more example which you will see in the cricket, right? When you are catching the ball, no? When you are catching the ball, the fielder used to take his hands towards back. Why? He doesn't want to get injury by the ball or get hit by the ball, right? No, the cricketer allows a longer time for his hand to stop the ball. He is taking the ball with respect to hand. Yes, no? Yes. He draws in the hand backward in the act of catching the ball. The novice, on the other hand, keep his hand fixed, tries to catch the ball almost instantly. The novice like another person, okay? He needs to provide much greater force to stop the ball instantly, and this gut hurts. If I am taking too much time to stop the ball, no, like almost ball has came, but I am taking my hand backward, obviously the ball also will come with me only, and I can catch easily with no hurt. But if a ball is coming with high speed, I am catching like this simply, I get hurt in the hands, right? No, this is where we can use this momentum in day-to-day life applications. Okay. Yes. So force not only depends on the change in momentum, but also how fast change is brought about. Yes, the same change in momentum brought about in a shorter time needs a greater applied force. The same force at the same time causes same change in momentum for different bodies. Yes, that's the thing we have seen in the previous 3 slides, the examples, right? No? Yes, I guess it's clear. We'll go for the next one. Newton's second law of motion. So first law we have completed. Now the second law. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which force acting, which means momentum is equals to mass by velocity. So rate of change of momentum is directly proportional to the applied force. No, they are saying. So dp by dt will be equals to d by dt of m into v, where m is constant. I can keep as it is. So dv by dt, which is nothing but acceleration. The rate of change of momentum is nothing but force. So dp by dt is equals to mass into acceleration, which is nothing but F is equals to ma. So many people have doubt in this, like whenever we are asking the Newton's second law, they were saying that F is equals to ma. No, it's a rate of change of momentum of a body directly proportional to the applied force and take place in the direction of the force acting. That's it. Rate of change of momentum directly proportional to the applied force. That's called as Newton's second law. Okay, you can take a note of this. Done? Clear? Okay. So F is directly proportional to delta P by delta T. Excuse me. So by derivations, no, we got the formula F is equals to ma. So 1 Newton, like what is the SI unit of mass kg, SI unit of acceleration meter per second square. So 1 Newton will be equals to 1 kg meter per second square. Either I can say it's a 1 kg meter per second square or 1 Newton. Okay. Yes. So 1 Newton is the force that causes an acceleration of 1 meter per second to a 1 kg body. This is important thing. Like they can ask, 1 Newton is the force that causes an acceleration of 1 meter per second and 1 kg for the 1 kg body. Okay. Then completed. Okay. So some important points about the second law. Okay. So in second law, no, if F is equals to 0, it implies that acceleration is also 0. Like mass, I can't say mass is 0. Mass will be there. If acceleration is 0 only, then F will be 0. The second law is consistent with the first law. A force is always parallel or anti-parallel to the velocity of a body. So if I see here, force will be parallel or anti-parallel. Here if you see, Vx is perpendicular to the force, Vx remains constant. Vx is perpendicular to the force and Vx remains constant and Vy is anti-parallel to the force. The component of velocity normal to the force remains unchanged. So, parallel or anti-parallel velocity can be changed, or it can be it can varies, okay, but perpendicular forces will be remains unchanged. See here, if I talk about a projectile motion, like I can resolve into two components, one is Vx and one is Vy. So, Vx is perpendicular to the force and Vy is anti-parallel to the force, right. So, this is some important points about the second law. Done. So, next point, second law of motion is applicable to a single point particle. If F is a net external force, no, acting on a particle, and A stands for acceleration, yes, of a particle or center of a mass of the system. Of course, right, and any internal force in the system are not to be included in the F. Not to be included in the F. This is the third point. First point, what it is? F is equals to 0 means implies A equals to 0. And second point, force is always parallel or anti-parallel to the velocity of a body, and the component of a velocity of normal to the force remains unchanged. That is second point. And third point, second law of motion is applicable to a single point particle. Okay. Done. Yes. Here is the question. A bullet of mass 0.04 kg moving with a speed 90 meter per second enters a heavy wooden block and stopped after a distance of 60 centimeter. With what is the average resistive force exerted by the block on the bullet? So, let me write the things, given things here. Mass equals to 0.4 kg and speed V is equals to 90 meter per second. Wooden block and stopped after a distance. Stopped means the initial velocity u, final velocity is v, 0. So, S is equals to 60 centimeter. What is the resistive force they are asking? So, can I use the kinematic equations to find, first of all, resistive force they are asking, no, resistive force they are asking. What is force formula? F is equals to mass into acceleration. Mass they have given. What about acceleration? I don't know. They have given remaining three things like initial velocity, final velocity and displacement happen. So, displacement here 60 into 10 power minus 2, which is nothing but 60 by 100, 0 0 will get cancelled, 0.6 meter. So, first I will use I will write the kinematic equation. V is equals to u plus at. I can use this one, t is there. V square minus u square equals to 2as. Yes, I can use v square, I know, v I know, u I know, and s also I know. Yes, I can use this only directly. So, v square is 0 square minus u square is 90 square will be equals to 2 into a into s is 0.6. 0.6. So, this one minus 81, no, minus 8100 divided by 2 into 0.6 will be equals to a. Now, this I can substitute in place of F. They are asking resistive force. Why I am getting in minus resistive, like opposing force only? No. So, F will be equals to mass into acceleration. Mass is 0.04 into 8100 divided by 2 into 0.6. 0.6. So, if I substitute this one, no, like I can take this 20 and multiply here. So, 81 into 4 divided by 2 into, and I can multiply 0 here and 0, I mean 10 here, 10 here. So, into 10 divided by 6. So, this is 2 times and this is, so 1 time and this is 2 times and this is 2 times and this is how much? 2 and remaining 2, 7, 27 times, no, 27 times. So 27 and this 2 will get cancelled. 270 minus 270 is the resistive force, no? Yes. So this is how we will solve the questions. This is how we will solve the questions. Right now, I'm getting, we are doing the correct answer only, no? Or let me check it once again. So what is the thing? 0, 4, no? I can take these two zeros. So that 4 into 81. To remove this point, I'm multiplying 10 by 10, which is into 10 divided by 2 into 6. Fine, no? Yes. Now this 2 times and this, sorry, 1 time and this is 2 times, and this is 2 times will go, and this is 27 times it will go, no? 27 times. Yes. 2 times and 2 3s are 6, remaining 2, 7. Yes. So 27 times, okay, fine, and this 2 and this 2 will get cancelled off again. So 27 into 10, which is nothing but 270, and this minus is there, minus 270. So minus 270 is the answer for this question. Minus 270 Newton, or else kg meter per second square, right? Okay, I hope it's clear now. So there is a homework question for you. The motion of a particle of a mass is described. Motion of a particle of a mass is described. Y is equals to ut plus of gt square. Find the force acting on a particle. Find the force acting on a particle. This is the question. This is homework question. So complete it before coming to the next classes. And whoever watching in online, no, you guys can take this question in a screenshot, or else if you are having a book in front of you, you can write the questions and get the answer. And if the answer should be given in the comment boxes, so that we can cross verify the answers. Okay. Okay guys, so with this we'll end this session. Okay, so we'll come with the next part in the upcoming sessions. Okay, thank you guys, we'll meet in the next class.